Hello everyone, welcome to Concepts Eco, Concepts from Experts. So this session is about chemistry bridge course and foundation course, which is helpful for both the students who passed 10th class and awaiting intermediate or 11th class. And those who are pursuing 8th and 9th class also, they can also listen to these classes so that they can understand the basics of the chemistry. So let us go into our session. Today's session is some basic concepts of chemistry. So this is the session title, and we are going to discuss what are the different types of matter properties and measurement systems and laws of chemical combination and all, atomic theory and all these things we will discuss in this topic. Let us jump into our topic. Okay, so please don't miss the session. Listen to the total class. It will be very useful for you for getting good score in your competitive examination that you are going to appear. Okay, now subscribe to our channel Concepts Eco for getting the updates, and if you like the video, just put a like to encourage us for making more videos, and also share with your friends and family members who are our cousins and all, so who needs this topic. Okay, so first of all, matter and its nature. First topic is matter and its nature. So matter means any entity, physical entity which has mass and volume. So any object which has some amount of mass and which occupies volume is considered as matter. Okay, so matter means which is having some amount of mass. So matter means, so it will be having some mass as well as some volume. So if both are there, then only we consider that as a matter. Okay, so that is a matter. Now again, classification based on the physical states. There are three classifications. One is solids, which have definite volume and definite shape. If you look at a solid material like a mobile phone or a laptop, so it will be having a definite shape and always the volume is constant. It will not vary with time. Similarly, liquids, if you take whenever you pour some amount of liquid, the volume of the liquid will not change, but the shape. If you pour water in a bottle, it takes the shape of the bottle. If you pour the same water in a balloon, it takes the shape of a balloon. So like that, water does not have any shape, but it has a volume. So liquids have a definite volume, but they don't have a definite shape. If you look at gases, so they don't have either volume or they don't have a shape. So wherever you see how much volume of air you can fill in a same cylinder. Okay, so volume is not definite as well as the shape is also not definite for gases. So chemical composition of matter. So matter, what matter contains. So either the matter may be a pure substance or it may be a combination of two or more substances. For example, pure substance, if you take like hydrogen, oxygen, nitrogen, in that if you look at hydrogen, so it will contain only hydrogen. We cannot derive anything else other than hydrogen in hydrogen. Okay, so how many pieces you make hydrogen, you will get a hydrogen only. You will not get oxygen or any other compound from hydrogen. So those are the basic simpler substances are considered as elements, so which we cannot further divide it. Okay, so whatever you divide, you will derive the same substance is called element. Compound means, so group of elements which forms a compound. So in this the compound is a homogeneous mixture of elements. Means if you take water, it is a combination of hydrogen and water, oxygen, hydrogen and oxygen, H2O. So wherever you take, if you take water at anywhere, it will its composition will be H2O only. It may be taken from Bay of Bengal, or it will be taken from Arabian Sea or Indian Ocean. So from wherever you derive water, you get water, and check the composition, its composition will be H2O only. So likewise, so where the H2O can be broken down using electrical energy, we can break them into hydrogen and oxygen. So they can be further divided into simpler substances. Those are called compounds. Okay, so by chemical change, so they can be separated or reacted. So those kind of entities are considered as compounds. When you take mixture, it's a physical composition, physical combination, physical methods. Using physical methods, if you are combining something and by using the same physical methods, we can separate them. Okay, so they have variable composition. For example, if you take sugar and water, so you are adding sugar and water, that is sugar water. Okay, it's a lime in water. So lime water. So mixtures can be homogeneous, it can be heterogeneous depending on the concentration of the these mixtures. If the concentration of sugar, if you mix the sugar in water completely, so every droplet will be sweet. Okay, so you cannot find some droplet as having not having any sweet and some droplet is much sweeter. So we cannot find like this. The sugar is completely mixed with water. Every droplet of water will be sweeter. So means what? The sugar is evenly distributed inside the water. So this kind of combination where the various compounds which are mixed uniformly mixed completely throughout the solution is considered as a homogeneous mixture. If you add sugar and salt, so or else if you go to a movie theater, you ordered a caramel popcorn with cheese popcorn. So if you mix them both, so you will not find only caramel everywhere, or you cannot find cheese equally everywhere. So sometime you will get more caramel, sometime you will get more cheese popcorn. Means what? This is a heterogeneous. It cannot be combined fully uniformly throughout the mixture is called heterogeneous mixture. Okay, so these are the chemical composition of the matter. Okay, so these are the physical quantities and their measurements. Whenever you measure anything, when you want to do any kind of calculations, you need the physical properties and their physical quantities and how to measure them. So what are the SI units of them? All those things are very much necessary. So even though it is chemistry, so there is nothing like we don't need physics at all in chemistry. This is a physical chemistry, so where physics is involved. Okay, now definition. So mass, length, time and temperature are the physical quantities. Generally these are the basic physical quantities that are necessary to derive, to find, to do any sort of calculations in the chemistry. Okay, so these are expressed in a numericals and units. So whenever you say anything, the mass means 10 kg. So 10 is the numericals and kg is the unit. Okay, so sometimes the unit may be a basic unit, or sometimes the unit may be a derived unit. So what is meant by a derived unit means, if you are taking the mass is 10 kg, then weight is 10 Newton. So the Newton is again a derived quantity, because so see here, so the weight is what? Mass into acceleration due to gravity. So the mass is a basic unit, it is having a unit of kg, whereas this g is the acceleration, which is our unit of meter per second square. So combinedly it is called a Newton. So we are deriving it from kg and meter per second square. Using these two units we are deriving this Newton. So Newton is a derived unit, not a fundamental unit or not a basic unit. So the base units generally we take for 7. So 1, 2, 3, 4, 5, 6, 7. So there are 7 fundamental quantities in physics or chemistry, wherever in science. So those are, one is mass and its unit is, basic unit is kg, and length, the basic unit is meter, and time, the basic unit is second and represented by S. Temperature Kelvin, electrical current ampere, it represented by A. Luminous intensity candela, it represented by CD symbol, and amount of substance mole, we majorly use this mole for chemistry, that is represented with MOL, is a symbol of mole. So these are the basic units, and all the other units which we derive using these 7 units are called derived units. So there are 7 fundamental units or basic units. So using these 7 fundamental units, we multiply, we divide each other, and we will get some kind of units are called derived units. Key temperature facts. So generally, so when we freeze any object, any object, its temperature will get 0. So somewhere, so there is an absolute zero. So that absolute zero means what? Generally in a Boyle's law, if you look at the volume and temperature relationship. So volume and temperature relationship. When you increase the temperature, the volume of the object increases. When you increase the temperature, volume of the object increases. So let us say this is the graph of the volume of the object. So that means what? When you increase the temperature, the volume of any object is increasing, means when you are reducing the temperature, the volume of object will decreases, right? When you are reducing temperature, the volume of object will decreases. So when you are decreasing it, it gets somewhere. See this graph, this volume is closely asymptotically meeting the x-axis at some point. So this point is considered as absolute zero, and this value is equal to minus 273.15 degrees Celsius is considered as 0 Kelvin. So whenever we increase the temperature, the volume of any object increases. In the same manner, in a similar manner, when you reduce the temperature, the volume of object becomes 0. So when you come back, it will meet the x-axis at some point. Is that point is taken as absolute 0, where the volume is nearly 0. Okay, nearly 0. It's not exactly 0. There is amount of substance is there, so we cannot say it is 0, but it is nearly 0, and that temperature is called absolute 0, which is equal to 0 Kelvin, or it is equal to minus 273.15 degrees Celsius. So the same thing reversely we can match that K is equal to degrees Celsius plus 273.15. In the same manner, Fahrenheit, these are the scales of temperatures. We will discuss more about these scales of temperature in heat topic. Okay, in thermodynamics, both in chemistry and as well as in physics. Okay, so we will discuss about these relations and all. We don't go in deep here. We will go and study in the separate lesson on this. Okay, so derived units, example I have told you already, density. So where we are using kg and meter cube together, we are deriving the unit as kg per meter cube, which is a derived quantity. So derived from mass kg and volume meter cube. So this is an example for derived quantity. In the same manner, we use the fundamental quantities for deriving the other quantity units. Those are called derived quantities. Okay, so next is precision versus accuracy. So whenever we do measure, see what is the closeness of multiple measurements to each other. For example, if you see here 45.2, 45.1, 45.3, 45.2, so these values are nearly at the same point, but the true value, see, true value is 50, but it is far away from the true value. See, precision means whenever you do a measurement, you will get some reading. When you are standing on a weighing balance, so the weighing balance should show your weight, but the weighing balance is showing actually your true weight is 50 kg, for example, but the weighing balance is always showing 45.2, 45.1, 45.3, like this. If you look at the weighing balance is having the precision, but it is having low accuracy. The accuracy means what? Closeness of the measurement to its true value. So how close is your value to the true value is considered as the accuracy. So if you look at the example here, so 45.2, 45.1, these are all high precision values, but they are lacking accuracy. If you look at the second set of measurements, 48.5, 52.1, 49.2, 50. These are all nearly equal to 50, but they have good accuracy, but if you look at the readings together, they are far away to each other. So 48, 52, there is a difference of 4 kg. So means what? These values are having low precision, but they have high accuracy because they are all very near to 50. They are all very near to 50. Similarly, in case 3, if you look at case 3, high accuracy and high precision. So here the readings are nearly equal, nearly same. The difference between the readings are same, means what? They are good, precise, as well as the value closeness to the true value is very less. So that means that these are very highly accurate and highly precise values. This is the difference between precision and accuracy. Okay, so values are close to each other but far from 50, high precision, low accuracy. Value average close to 50 but are spread out, which are far away from each other, is called high accuracy, low precision. Values are close to each other and also close to 50 means what? High precision and high accuracy. So this is how we look at the precision and accuracy. Okay, so significant figures, very important in your examination. Okay, so always this concept will cause you some kind of difficulty, but when you listen to this video, so that significant figure will be very clear to you. And the same thing we will discuss in physics also in the lesson name called units and measurements in a very better way than this. Actually, this is also a better way. In addition to this also, we add some more examples and some more clarity to the significant figures in physics also. So let us see definition. So meaningful digits in a number including the last uncertain digit. So see, whenever we make a measurement, we will get some amount of decimal values. So we will get some amount of decimal values. Okay, so these are clear figures. These are clear whenever you do any calculation. So after decimal, the values may slightly vary. So that will affect the final value. So these significant means what? It got some significance. Significant figure means what? The numbers has got some significance, means what? If you change that number, the final result will vary. It will affect the final result. Those are called significant figures. So significance, they got some amount of significance in the calculations. So whenever we do any experiment, we record some values. When you are adding some acid to a base for checking a neutralization reaction, you got some amount of acid that is added. So if you get the measurement, get the volume of the acid, and you are measuring it up to very accuracy, up to having more number of significant figures, then that will yield you very high precise values and high accurate values. So that is the necessity of these significant figures. Okay, for example, so there are some rules for identifying the significant figures. So with examples I am showing, all the non-zero digits are significant. If you look at this number, so there are many numbers which are all are non-zero. So because so as per this rule, all are significant, because here that means how many are significant here? 5 significant figures are here. Zeros between non-zero digits are significant. See, this is one non-zero digit and this is another non-zero digit. In between there are 2 zeros. So these 2 zeros are considered as significant. So here in 1002, how many significant figures are there? 4 significant figures are there. Leading zeros are not significant. See, leading zeros. See, when there is no number, the number is starting with 0. So these 3 zeros are not significant. Only this number has got 3 significant figures. This number has got 3 significant figures. In the same manner, see here the difference. Trailing zeros are significant only if there is a decimal point. See, trailing zeros are significant only if there is a decimal point. See here, this 0 0 is not significant, but here, so these 0 and these 2 zeros are also significant. So when the trailing zeros are significant only when there is a decimal number. So here we are having 5 significant numbers. Here we have only 2 significant numbers. Here we are having 2 significant numbers only. Whenever we do addition and subtraction, very very important, answer should have the same decimal place as the least precise number. See here, say this is least precise number. 4.2 is least precise. It has got only 2 significant numbers. Here it has got 5 significant numbers. So whenever you add or subtract with 2 numbers, one number has got less number of significant numbers, another number has got high number of significant numbers. So then we need to give the result. We need to give the result with the lesser number of significant numbers. So which number has got less number of significant numbers? So that only we need to consider while reporting the result. So the result should be also have only 2 significant numbers. Okay. So answer should not have the same decimal places as the latest precise number. So one decimal place as 4.2 has got. Okay. So here in 16, so here, yeah, after decimal, how many significant numbers are there? That many significant numbers you need to keep here after decimal. Here 4.2, after point there is only one significant number. So in the result also we are reporting only one decimal number after one significant number after the decimal. So likewise we need to keep when doing addition and subtraction. Okay, answer should have the same decimal places, okay, as the least precise number. So in the least precise number, whatever the decimal spaces that are there in the least precise number, those many significant numbers should present after the decimal of the least precise number in the result also. Okay, multiplication and division, answer should have the same significant figures as the number with the least significant figures. Here 4.56, it has got 3 significant figures. It has got what? 3 significant figures. 1.4, it has got only 2 significant figures. So the answer should also get only 2 significant figures. So whichever number has got lesser number of significant figures, so those many should present in the result also. Those many should present in the result also. Okay. Now rounding, whenever you get a digit greater than 5, increase the last retained number by 1. Example, if you look at this 12.36, the last number is 6, which is greater than 5, greater than or equal to 5. Then we need to add a plus 1 to this 3, and it will become 12.4. Or else what he is saying here, rounded to if we want to round it to two significant numbers, if he is asking to round it to three significant, then it will be 12.4. See, 12.36 has got four significant numbers. I wanted to round it to three significant numbers. Then this is 6 is greater than 5. Then I need to add plus 1 to the before number. So then it will become 12.4. 12.4. If the same person is asking for 12.36 with two significant numbers, now, so 0.36, this 0.36 is less than 0.50, right? Or else 4, this 4 is less than 5, this 4 is less than 5, then we don't add anything here, we add just 0, then it will become 12, okay. So 12.34, next digit is less than or equal to 4, then leave it unchanged. So here this is 4, less than or equal to 4, then we don't change the number, simply remove the number and report it as 12. Are you getting the point? Additional examples, if you look at this, this is having 5 significant numbers because zeros in between any number is considered as significant. Here the leading zeros are not significant, but a trailing zero is significant. So this is having two significant numbers. Here the leading the zeros between the number is significant, as well as 0 after the decimal is also significant. So it has got 1, 2, 3, 4, 5 significant figures. So in the same manner we have to report the significant figures. I hope you have understood. If you don't understand also, you can listen to the same lecture again and again so that you will understand with the examples also. Now, dimensional analysis. See, a method used to convert units from one system to another system. So we use unit factor method. Means what? For example, we have got 1 meter. Okay, we have got 1 meter. The same meter can be converted into centimeter also. Then it will become 100 centimeter. So this is called a number. This is called unit. So whenever the unit is more, when a unit is bigger, so unit is bigger, then the number will be smaller. Because see, here centimeter is a smaller unit, meter is a bigger unit. The number before the meter is just 1. The number before the centimeter is 100. So the number will be more when the unit is less. When the unit is more, the number will be less. Okay. So dimensions of a derived quantity are the powers to which the base quantities are raised. Now, so either any dimension we derive. Okay. So the basic quantities, whatever the quantities are used in that, accordingly whatever the quantities you have used in deriving the dimensions. For example, I am using force formula, I am using mass and length by time square. Mass into acceleration means distance by time square. So here, if you don't understand this, I will elaborate this. Mass is acceleration, mass into acceleration is force. Mass into acceleration means velocity by time. Again, velocity means distance by time. Distance I am taking as length, so by time. Again, another time is here, so m into L by t square. So similarly, so dimensions are derived quantities, are the powers. See here, m is one basic unit, L is another basic unit, T is another basic unit. So now the dimension of the force will become m L T to the power of minus 2. T to the power of minus 2. This is what here discussion. Here it is discussed. Dimensions of a derived quantity. So this is a derived quantity and the dimensions are here. So these are the dimensions. Okay, are the powers to which the basic quantities are raised. These are the basic quantities and their powers are here: m power 1, L power 1, T power minus 2. Okay, so here this is called dimension. Here this is called what? Dimension. Dimension of a derived quantity are the powers of to which the base quantities are raised. If two quantities are equated, they must have the same dimensions or units. For example, if you are equating the force with m into a. Means what? The force and m into a should have the same quantities. Suppose, for example, we use a formula in kinematics. V is equal to u plus a into t. So v is velocity. So the dimension of velocity is length by time. So L t power minus 1. So we will discuss about these dimensions and dimension analysis in clear way in units and dimensions. I don't go in detail here because that is not relevant here. When you understand the units and dimensions topic, you will clearly understand what is this dimensional equality. Okay, so all these things we will understand in a clear way there. I am briefly explaining here. Okay, see, I have given you some dimensional consistency example also. So now here conversion of speed and units. So 60 kilometer per hour to meters per second. Whenever you convert this, so kilometer means what? 1000 meter, and 1 hour means what? 3600 seconds. So whenever you are converting this, that means 2050s or 200 fives and 200 18s. So 5 by 18. So we need to multiply this with 5 by 18 or 18 by 5 so that you will get the meters per second. So in the same manner, here dimensional consistency means what? I told you here, whenever you are using dimensional analysis, the left hand side dimensions should be equal to right hand side. The dimensions should be equal. See, here this is velocity. Velocity means what? Length by time means L t power minus 1. U is again velocity. Its a dimensional unit, dimensional quantity is L t power minus 1 only. And similarly, we have seen here acceleration is L by t square. Means what? Acceleration's unit is L t power minus 2. And you are multiplying again with the time means into t. So which together it comes to the power of 1 minus 2 plus 1 again. It comes as L t power minus 1. See, if you look at this, here the dimensional consistency. So they have the same dimensions. If you want to equate this velocity with u plus at, if you want to equate the velocity with u plus at means what? Right hand side and left hand side, the dimensions should be same. That is called dimensional equality or dimensional consistency. Okay, so this is about the dimensional analysis. We use this dimensional analysis for unit conversions in physics and engineering. So verifying equation for correctness. So whenever we write an equation, so if it is dimensionally consistent, then the equation is correct. When there is no dimensional equality, here we are getting mass dimension, on the other side, on the right hand side, we are getting some other dimension, then they both are not forming a correct equation. So we can find the correctness of the equation also using the dimensional analysis. Next is the laws of chemical combinations. So here, whenever any two or more than two elements or compounds react each other, they form a reaction. They form a chemical reaction. And how to understand the chemical reaction? We have got 6 laws, very important laws in the chemistry. Okay, so we will discuss about these laws in the next class. So stay tuned. In the next class, we are going to discuss this laws of chemical combination, Dalton's atomic theory, atomic molecular formula mass, what is meant by this, and equivalent weight, everything determining n factor, redox titrations, what is n factor in redox titrations, and mole concept and molar mass. So all these things we are going to discuss in the next session. So stay tuned, subscribe this channel, and refer with your friends if you like this video. So thank you so much.